I'm going to go through 2 or 3 homework problems from Math XL. This first one is from section 2.2 for MT125. It's asking this question: is a function even, odd, or neither? Remember, graphically, even means that the graph is symmetric with respect to the y-axis. Odd means it's symmetric with respect to the origin, which means if you flip it over the y-axis and then the x-axis, the graph will land on itself. And other possibilities, it could be neither even nor odd. Okay, so just to remind you, the algebraic condition to check is that if you plug a value into your function and it's opposite, you get the same result, and then g is even, if that's true for every number. If you plug a number in and it's opposite, they should be off by a negative, and that'll mean the function's odd. Okay, so for us to go through and check, we got to plug in the value. All right, and that just amounts to changing the letters from x's to v's. All right, so we get v to the 10th plus v to the 3rd power, and then we got to plug in its opposite and see if we get the same thing or the negative of that. All right, so we plug in negative v, we take our input, raise it to the 10th power, and then add on our input raised to the 3rd power. So we get negative v to the 10th plus negative v to the 3rd. When you raise a negative quantity to a even exponent, you get a positive result. When you raise it to an odd exponent, you get a negative result. So we get v to the 10th minus v to the 3rd. And we can see that that's not equal to our original, and therefore g is not an even function. Okay, and likewise, it's not equal to its opposite. All right, its opposite would be negating this entire quantity here. We have to distribute the minus sign through to each term, and that would give us negative v to the 10th minus v to the 3rd, which is not what we got by plugging in negative v, the opposite of a given value. All right, so in this case, our answer is that neither g is neither even nor odd in this case. All right, so going back to the homework, that's our answer. For this particular problem, the answer is neither. Okay, we check that out. All right, now I'm going to move on to a different problem from a different homework. All right, so moving over to section 2.3, this is on lines and linear functions. I'm going to check out number 9. All right, so the problem here wants us to graph the line given in slope-intercept form. So we got negative 5x plus 4. Okay, just to remind you, we have negative 5x plus 4. It's in slope-intercept form. We know the slope is the number in front of x. That's the rise over the run. So we can write that as negative 5 over 1, which would tell us to go down 5. It's the change in y over the change in x, and then right 1. Or if you put the negative sign on the bottom, it could be saying to go up 5 units in the positive y direction, and then left 1 unit to the negative x direction. Okay, the 4 at the end tells us that this is the height at which we hit the y-axis. Going back to Math XL, we want to actually plot this. So you're supposed to click on the graph or hit the magnifying button at the top there. Then you're going to select the line tool. If you hold your mouse on the second one, it says line tool, hit that. Then you put the first point on there. So let's put our y-intercept there. So just put it there, left click with your mouse, and then we're going to count down 5 units because our slope is negative 5 or negative 5 over 1. So we're going to go 1, 2, 3, 4, 5 units down to negative 1. Over 1 unit to the right, click down with your left button, then save it, and then Math XL will draw the line through there. That's all we're asked to do in that problem, was just to graph that line. Okay, let's also move on and do number 13, which is a similar problem. Here they're giving us the equation of a line in more general form. We're supposed to put it in slope-intercept form and then plot the equation. Okay, so let's go over and do that. To put this in slope-intercept form, you're just going to solve this equation for y. So we're going to subtract 12x over, add 8 over, and then we'll eventually divide by the coefficient of y, which is negative 4, to solve for x. Okay, so the resulting equation is then going to be negative 4y equals negative 12x plus 8. To isolate the y, we divide both sides by negative 4 and multiply by negative 1/4. Either way, okay. Remember, you have to remember though to distribute that to each term. Okay, divide each term on each side by negative 4. The resulting equation is y equals 3x minus 2. It should be here. Okay, it's a typo here. This should be a 2. Negative or 8 over negative 4 is 2, not 4. Okay, so our slope is 3, and we should have a y-intercept of 2, not, or negative 2, not 4. So let's go back over. All right, input that. We should have y equals 3x minus 2. Okay, so that's correct. The second part is similar to the last problem where we want to plot that line. So again, access the line tool, go down and put your y-intercept on there. It's negative 2, count up, in this case 3 units to 1, over 1 unit, save it, and then check your answer. And that's all there is for that problem.